Welcome to Digital Earth, Changing Colorado. We have a very cool program for you tonight. We're going to be covering all sorts of stuff. And as throughout the program, if you have any questions or comments, please put them in the chat. You won't be able to see everyone else's chat, but I'll keep an eye on it. And we have a program about an hour, a little bit longer. And then if you'd like to stick around, we'll have time for some question and answer. And with no further ado, I'd like to hand it off to Dr. Chun Yu, our curator of space sciences.
All right, thank you very much, Mitch, and welcome everyone to Digital Earth, Changing Colorado. And before we begin, I wish to acknowledge that we in Denver and at the Denver Museum of Nature and Science are on land today that is the traditional homelands of the Cheyenne and the Arapaho and the Ute, who are the original stewards of this land. And we also acknowledge other indigenous tribes and nations that make Colorado home. So let's go ahead and get started with Digital Earth. For those of you who haven't seen this program before or need a refresher, the philosophy of this program is exploring our planet Earth, our home planet from space. And we do that using planetarium visualization software. And we started doing this actually about 13 years ago in the planetarium. But since the pandemic, we've been going online and hopefully reaching a lot more of you, even people outside of Colorado. And what's exciting about this program is that what you're seeing is real data. We try to use real satellite imagery and other visualizations of scientific data from NASA, from NOAA, other US agencies. And the software is called OpenSpace. It was actually conceived at the American Museum of Natural History, our counterpart in New York City, and it's funded by NASA. And with that, one final note is that I will be flying and driving us around, and so I'll disappear and turn it over to Bob.
Great, thank you very much, Chun, and thank you, Mitch, for getting us started here. Welcome everybody to our Digital Earth program on changes in Colorado. And we have a wonderful opportunity here to look at changes through vast amounts of time and space. And I'm a geologist and I'm a research associate at the Denver Museum of Nature and Science. And I'm going to share my screen, and this is going to be, it'll take a couple of minutes to get through this, but we're going to go to a website called coloradostratigraphy.org, and that's all one word. And bear with me as we go there. It'll take a couple of clicks and I will pull this up. And Mitch?
And we're seeing it, it looks good.
Okay, so I never know quite what you're seeing. So I'm delighted that you're seeing my screen. And this is a stratigraphic chart, and it's organized like a spreadsheet with the columns being areas of Colorado, different basins and different regions of Colorado. And then the rows are geologic time, going back even beyond the Cretaceous, all the way down to the early part of the Paleozoic at the bottom of the page. And I just want to remind everybody that the geological record of Colorado is wonderful. It's extremely well studied. There have been generations of geologists working on it literally for hundreds of years. And we know quite a lot about the evolution of the landscapes of Colorado. And I'm going to walk you through it just quickly from the bottom up. And I'll just say that the first few hundred, we're going to start at about 540 million years ago, which is the beginning of the Paleozoic. And the names aren't that important, but suffice it to say that the first several hundred million years of Colorado's history, the seas came in and the seas went out, and you preserve rocks that look like sandstones and limestones. And it was what we call a passive margin. It was on the west side of the North American Craton, and the landscapes had marine environments to the far west and continental environments for Colorado is mostly. But we accumulated things like, some of you might have seen the Leadville limestone, which is very well exposed around the town of Leadville during that time. And then we had something we call the ancestral Rockies that happened about 350 million years ago, and a long time ago, but it left a remarkable record. And some of the orange units in here that you can see, you'll see the name Fountain Formation, you'll see the name Maroon Formation. These are some of the red beds that came off of the ancestral Rocky Mountains. And so there were Colorado's changed from being a passive margin, which would be relatively low relief, to suddenly having relatively high mountains, and we don't know quite how high they were, but deep basins filled with salt and marine rocks, and also filled with red rocks. If you've been to Maroon Bells, if you've been to Garden of the Gods, and of course our own Red Rocks Park right here behind Denver, and the Flatirons up at Boulder are made up of these red beds. After the ancestral Rockies formed, the basins filled up with sediments, and the mountaintops that had been high eroded flat. And we have this wonderful record of the Morrison Formation, which many of you will be familiar with. That's present out at Dinosaur Ridge. It's got the dinosaur bones in it at Dinosaur Ridge, and also at Dinosaur National Monument on the Utah, Wyoming, Colorado border. And that Morrison Formation represents sort of a healing of the earlier landscape. What had been high had been planed off, and what had been low had been filled in. The Morrison Formation goes across the top of almost everything. And then the Morrison Formation is followed by what we call the Cretaceous Interior Seaway. And the blue color here represents the marine environments that were here starting around, they would have started about 100 million years ago and extended up until about 65 odd million years ago. There was marine environments in Colorado. Then the ocean dried up. The Cretaceous Tertiary boundary took place. And we have a variety of very interesting basins, including the Denver Basin, the Raton Basin, the South Park, North Park, Middle Park basins, and basins out in the west, which would include the San Juan Basin, the Piceance Basin. And those formed during what we call the Laramide orogeny, which was a mountain building episode that resembled in many ways the ancestral Rockies, but it's the modern, the so-called modern Laramide orogeny. And after the Laramide orogeny, which it faded out about 54 million years ago, again, the landscapes healed over, and many of the basins filled up with sediments. And there was a time about 30 or 40 million years ago when the landscapes were relatively flat in Colorado. And then recently there's been uplift, and the river systems have been sized, and there's been what we call headward erosion to give us the modern landscapes that we see today. Now I'm going to show you a couple of other tricks that are on this website. I'm just going to show you, we have a series of paintings that have been made to show some of these landscapes. And if you mouse over the painting, you'll see the modern landscapes there, Highlands Ranch. And then we step back through time, and I'm just mousing over those green boxes, and you can see the landscapes changing. We go into the interior seaway. We have beaches, and we have the Morrison Formation with dinosaurs, and so on. And we go back through time. So you can see paintings, the paleo paintings. Many of them are done by our friend Jan Vriesen. Many of them are in the Ancient Denver's booklet that some of you have, and many of them are also on the walls at the Colorado Convention Center. We've also worked with our colleague Ron Blakey, and we have paleogeographic maps of Colorado showing change through time. And I just touched on the map icon there, and now these green boxes represent views that you have of ancient landscapes of Colorado. And I'm just mousing over them as we go back in time, and you can see the changing landforms. And I'll just emphasize again the interior seaway. You can see Colorado is completely covered by water at 85 million years ago. And you go back, and then you start to see the seaway coming in at about 100 million years ago, and so on and so forth. So these are things you can experiment with at home. If you look at the website, it's called coloradostratigraphy.org. It's all one word. And it's been the product of many years of work, and there's lots of stuff in there. So that gives us the geological setting. I'm going to stop sharing my screen, and I'm returning to you visually. And we're going to now carry the story forward. So we've set the framework geologically, but now we're going to start looking at what things have looked like in Colorado through more recent time. And we're going to take you down south of Colorado to New Mexico, and Kachun's going to fly us down towards a little white spot that you can see there in New Mexico. And it's actually, it's a lake bed near White Sands, New Mexico. And you might have heard the recent news. It was reported in Science magazine just about a month ago, a series of footprints found here. And these are the first footprints on the North American continent that we know of. And they are about 18,000 years old. They've been dated carefully. And you'll see a lake here. This is a dried up lake where it's in the White Sands National Monument. And it represents a dried out lake. The white sands that are in this region are composed of gypsum that have blown off the dried out lakes. And it's a remarkable sand dune. Some of you might have been there. The sand feels cool to the touch, even on a hot day. And it's very soft. You can actually take a little mouthful of it and chew it. And it's not like silica sand. It's made of gypsum, very soft. The dunes are very beautiful down here, the blowing gypsum dunes, and they're covering flat-lying ground that represent old lake sediments. And the lake sediments have been eroding, and people have been looking at them over the years. And a variety of traces had been observed in these lake beds. And probably over the last 8 or 10 years, they've been excavating them. And there was a tremendous burst of excitement when they were published about last month. And you might have seen they were on the front page of the Wall Street Journal, of course, big article in Science Magazine. And here's a photograph of the footprints. They are magnificently well exposed. Many of them are trails that go for quite some distance and have been interpreted to be, there's one that's interpreted as a mother carrying her child, occasionally letting her child walk by her side. You can see in the middle picture there, and then she picks the child up again. And the footprints have been dated using carbon-14 from associated grains of grass seeds that are in the sediments. The dating looks pretty good, and everybody is amazed at the character of these 18,000 years. You might remember that we were discussing whether the first people had walked into North America at 10,000 or 12,000 years ago. Lots of arguments about that. And then grudgingly, they might say 15,000. But to have it step back to 18,000 with incontrovertible evidence of these first footprints lightly walking across the lake beds here in New Mexico. And our presentation this evening is going to talk about the footprints of man in Colorado and in the western part of North America. And you'll appreciate by the time we get to the end of the show that our footprints have gotten somewhat more impactful. So we started out very light-footed, and we've become more impactful through time. We're going to leave New Mexico and head back up. Oh, let's one last view. This is a magnificent image that was created by the Park Service people, and it shows the multiple horizons of footprints in the White Sands area. And you can see that the people were walking amidst camels and mastodons and giant sloths, as well as other large animals, many of which, of course, are no longer with us. And there's a lot of discussion about whether these animals met their demise at the hands of these early hunters. That's an ongoing topic of discussion, but it is part of the impact of humans on the landscape. It is very clear that relatively shortly after people arrived in North America, the megafauna, the large animals, went extinct. And the camels went extinct, the horses went extinct, the sloths went extinct, and the mammoths and mastodons went extinct. So that's a big change on the landscape of Colorado. But if we now, we'll leave New Mexico and come to our own backyard here, we're going to come up to Boulder, just northwest of Denver. And Chun's going to fly us down towards Chautauqua in the west side of Boulder. And this is an amazing story here. A few years ago, maybe 15 years ago, a fellow was digging a fish pond in his backyard in Boulder. And his assistants said that they were finding strange looking stone artifacts. And they laid them out on a picnic table and sort of looked at them and said they certainly look like artifacts. And they called up the museum there on the campus of CU Boulder. And the archaeologist of the museum said, well, it sounds preposterous, but because you're so close, I'll come on over on my lunch hour and see what you've got. And he came over and he was astonished when he saw the material laid out on the picnic table. And it's just a little right down there to the right. And I could almost point you to the backyard, but it's on the right-hand side of your screen in the backyard of one of those houses, right near Chautauqua Park, between the creek and Chautauqua, is where this site was. And it was a cache of stone tools, and the archaeologists recognized them immediately as being Clovis-style tools. And not only that, he recognized the composition of the material of which the tools were made. And these are the size of your hand. So I don't have a hand for scale, but the bigger ones are the size of your hand. And there's 62 or 70 pieces of material, some that are just rough blanks to be made into tools, and others which represent these beautiful blades and cutting tools that you can see. And he recognized when he looked at these tools, not only that they were of Clovis style, but he recognized that he knew where the rock came from that made the tools. And some of the quarries were in western Colorado, some of them were in southern Wyoming. And it was very clear that the person who had carried these tools to Boulder had either traded them or had walked long distances to get them. And they were made from materials that come from known ancient quarries, where particularly beautiful flint and chert can be found. Ultimately, they analyzed the tools, and the edges of the tools had DNA from blood of both camels and horses. And so it's very clear that the people who were hunting in Boulder were hunting camels and they were hunting horses. And of course, our understanding is that these animals were hunted to extinction. And the Clovis tools here are dated at about 13,000 years. And I would encourage all of you to go to the museum at Boulder. It's downstairs in the museum, this beautiful display together with a lot of additional ancillary material describing the Clovis cache from Boulder, Colorado. So again, earliest settlers coming into our area would have been 18,000 to 13,000 years ago, a long time ago. And the people who arrived here were skilled hunters. And the evidence is that they hunted some of these big animals to the point where they went extinct. And the exact mechanism whereby they went extinct is subject to some debate, but it is clear from the paleontological record that they were rendered completely extinct. And of course, the Denver Museum has excavated mammoths and mastodons. We've excavated camels. So we've found these animals in the rock record. But there was a long period of time when they were not here. In fact, and it wasn't until, after 1492 in the early 1500s that settlers came from Europe, coming across the Atlantic, and they brought the horse back. So the horse returned to Colorado in the 1500s and became a very important inhabitant of the high plains, of course, heavily used by the ancestral peoples who loved the domesticated horse and used it in their culture. But the area that we're going to visit here is you might recognize the city of Denver. We're going to be looking at the South Platte River, and I'll just remind you of the origins of the city of Denver, located, really near the confluence of Cherry Creek and the South Platte River. And it was gold that attracted a lot of the Europeans to Colorado. And the gold prospectors came to the river gravels and they prospected for gold right on the South Platte River, on the Cherry Creek. And gold was found in moderate quantities, sufficient to cause excitement. And so the city of Denver was founded in part to supply the miners. And of course, the miners chased the gold up into the mountains and searching for the mother lode. And they found great riches in what's today Central City and Black Hawk, for example, in Georgetown, Idaho Springs, and that country. We're looking here at our modern view of Confluence Park, which is the location where the Cherry Creek is coming in from the left, joining the South Platte, which is flowing obliquely across the scene. And this is a wonderful place. We've taken field trips here from the Denver Museum. You've got the REI building there. They're in an old power plant building that used to supply power for the cable cars in Denver. And there's a kayak place here, and you'll see mothers letting their children wade in the waters. Of course, these waters used to be tremendously polluted. It was sort of the it was really the sewer for the urban areas, and people used to throw their used cars and refrigerators into the South Platte River. And back in the 1965 flood, which some of you might remember, wiped out many of the bridges in Denver. It also moved a lot of the debris in the South Platte River, which included the cars and refrigerators. And it was quite a mess there. And they started cleaning up after the flood of 65. They built flood protection devices. Again, big changes in Colorado's landscape with the Cherry Creek Reservoir and Chatfield Reservoir and Mount Carbon reservoirs being built to protect the city of Denver from flooding. And so the landscape has been constantly evolving. Recently, they built this giant apartment building you can see there that overshadows Confluence Park. And to me, a little bit of a chagrin that we installed a giant skyscraper apartment complex on top of a beautiful park, but that's the way the real estate worked in this area. But the region has been cleaned up tremendously. When I said that people let their children swim in the water, it's true. Water that used to be heavily polluted is now less polluted, and it's a beautiful place to go. And the Platte River, the South Platte River, now forms a sort of a central corridor of ecosystems that are beautiful in downtown Denver. And the railroad systems have been largely taken out, and there's big park areas that are opening up along the South Platte drainage. And that project is ongoing as you move up towards the fairground, up towards the stock show grounds. There's again use of the South Platte River as a recreation and scenic splendor. And it's important to remember that didn't happen by mistake. It took a lot of effort on the part of many people to change the old polluted water and the polluted landscape into something that we can be proud of and enjoy today. So that's an example of significant change in Colorado. Another change I'll just mention is that some of you might know the history of the South Platte River. It used to run episodically. It would dry up in the summertime. And the water was still there, but it was in the sand, underneath the sand. And Michener wrote a book about that, some of you might have read. But today the river flows perennially, meaning all the time. And part of the reason is because it contains a huge proportion of water from the Colorado River that's been brought into the Front Range area and is used as municipal supply by the cities of the Front Range. And the wastewater goes into that river and flows downstream. So the river never dries up anymore. And that's created an ecosystem corridor that goes all the way along that river. We're going to think about Colorado now in terms of changes through time. And we've got several ways we're going to try to illustrate this for you. We're going to look at some views taken near Westminster. And this is an area just northwest of Denver. The view is to the northwest. And this is a photograph that was taken by William Henry Jackson back in about 1892. And if you can see that the Flatirons of Boulder are off on the horizon, and he's looking up across what might be Broomfield today. And if we look at it today, Rick Wicker from the Denver Museum took a photograph here in 2011, and you can see it looks a little bit different today. And you can see, again, the Flatirons of Boulder off on the horizon, but the entire foreground of the photograph has been changed dramatically. And we might flick back and forth, Chun, just to show the change in more detail. If you look at these two photographs, again, side by side or one on top of the other, the transformation is astonishing. And of course, this transformation has been made by people. The people have come here and they've watered the trees, they've watered their lawns, and we have planted those trees. The trees that you see in the photograph that Rick took in 2011, every one of these trees was planted by a person, and every one of these trees is maintained by watering the trees. In some cases, they're watering their lawn, and they're inadvertently or less inadvertently, they're also watering their trees. So the landscapes of Colorado have changed dramatically through geologic time. They've changed dramatically in recent times, and the hand of man is written on the landscape. And one of the themes of the next few minutes of our talk is going to be looking at changes in different fields, different topics, and we're going to cover changes in population, in temperature, in water supply, in energy sources, and also in fires. And we're going to spend a little bit of time on each of those topics and look at how changes are occurring. And you'll appreciate that in every case, we're looking at an accelerating rate of change. So the changes that we've seen in the far distant past took place slowly over geologic time. The changes associated with the arrival of humans started an acceleration that continues today. And we're going to look, for example, at the population now. If we look at population change in Colorado, we're looking at the state of Colorado. And this is a map that was produced by the State Demographer's Office. And the color codes here in red show areas that are increasing in population, and in blues, areas that are decreasing in population. And we're looking at a 10-year time span between 2010 and 2020. And you can appreciate that the red is located along the Front Range. And if we had the spatial orientation of the people, where the people are, they're going to be located in the urban areas that would range from Fort Collins down through Loveland, Berthoud, Longmont, Boulder, Broomfield into Denver, and then dropping south out of Denver towards Colorado Springs, and then to a lesser degree down towards Pueblo. And the main body of that population is between Fort Collins and Denver, or Colorado Springs perhaps. And those big counties look like the red goes out quite a ways to the east, but Weld County goes way out east, and there's not very many people on eastern Weld County. And Arapahoe County likewise goes way out to the east, and there's not too many people out on the east side of that county either. So this map shows change through time. And if you've been out to the Pawnee Buttes, or if you've driven out towards Kansas, if you get out towards Lamar, Lyman, out on the interstate, there's small towns out there, and you get out to easternmost Colorado, and agriculture is having a tough time out there for reasons we'll mention in a few minutes. And people are leaving. The young people don't want to stay in those small towns, and many of the towns are vanishing. Actually, if you go to Pawnee Buttes, the town of Keota is no longer there. There's a ghost town there, but that's a town that's was disincorporated in the last about 25 or 30 years. So these are changes in the distribution of people in Colorado. But let's look at some of the physical changes that are taking place. We can look at temperature change through time, and we've got a graph for the upper Colorado River Basin. So it covers a lot of ground on the western side of Colorado. But it's a very useful graph for our discussion here, because it shows data that goes back 100 years. And you can see that individual years might be relatively warm or relatively cool. That's sort of the spiky curve. And then if you take an average of that, that's the linear line that sort of goes from the lower left to the upper right. The linear line represents a climate change, while the spiky curves might represent more what we might call weather. So here's a distinction between the annual cycle and what the daily temperature is versus the long-term trend, which is actually the climate. And the climate is changing, and that's because of the change in the composition of the atmosphere, which is because of the increased greenhouse gas content of the atmosphere created through, again, human footprint, largely the combustion of fossil fuels, in which we've taken ancient carbon that was in the geological record that we looked at a few minutes ago, and we've taken that ancient carbon and we've put it into the atmosphere. And we have substantially changed the composition of Earth's atmosphere. And one of the consequences of that is an increase in the temperature, as you can see on this chart. With an average, you might say, well, it was somewhere near 43 degrees Fahrenheit average in the early 1900s. And today it's somewhere north of 45 degrees. So that's already a degree or more Fahrenheit of temperature change in the last 100 years. And the models indicate that these changes are accelerating. So what does this do to us as people living in this area? Well, here's an example. This is a map showing the change of extreme heat days, and it's the number of days per year above 90 degrees. And it's showing the the change in the number of days, again, with the darker red being lots more hot days and the lighter colors being not so many more hot days. But across the entire region, we're getting more and more days of intense heat. And of course, many of you will remember the past summer when we had the unbelievable temperatures in the Pacific Northwest, where temperatures exceeded 105, 106 degrees Fahrenheit in areas that had never seen those kinds of temperatures before. So our entire region, the state of Colorado and surrounding areas, is getting hotter, getting warmer. And as it gets warmer, we can look at the impact on our cities. And if we come back to the city of Denver and look at the impact of heat on the city of Denver, it's something that's tangible and felt by the people. And we're going to scoot down in and look at an urban heat island map for the city of Denver. And we've been working on this with several different areas, and people are gathering temperature data from urban areas from Richmond, Virginia, Spokane, Washington, across the country. And it is clear that we've had something called the heat island effect. Many of you have heard of that, where the downtown cities can be quite a bit warmer, sometimes 5 to 8 degrees Fahrenheit warmer than the surrounding countryside. And this map shows, again, the hotter areas in red and the less hot areas in orange, and then the cooler areas in yellow. And you'll see a pattern here that has been referred to as an inverted L. There's sort of an area along the interstate, the I-70 corridor that indicates warmth, and then that extends down towards downtown Denver. So you've got sort of a east-west phenomenon at the top of the map, and then a north-south on the left-hand side. And the hotter temperatures are associated with areas that are paved, areas that have a lot of hardscape, areas that don't have a lot of trees. And in many cases, this is a social equity phenomenon where some of the poorer areas, for example, up in the Elyria-Swansea area by the Commerce City, the Suncor refinery, those are areas that are relatively hot, and it's a tough place to live. And people are living there in conditions that are different than areas around City Park where the museum is, and in parts of central Denver where trees have been planted. Again, the downtown area, the hardscape, the pavement, and the absence of trees leads to this temperature anomaly. And it's really more of an archipelago rather than an island, but it shows the heterogeneous impact of heat on our own communities. And Chun and colleagues observe this. You can take a thermometer around and you'll see a difference in temperature as you move around Denver on a hot summer day. And there could be 5 to 10 degrees Fahrenheit difference depending on where your thermometer is and of course where your house is. So this is an impact on us. Those increasing hot days are things that we feel. And now we're going to transition to how it's affecting our water supply. Again, change in Colorado, increasing temperatures are affecting the water supply. And I think we'll start out with a regional view. We'll look at the overall drought conditions, and this is an updated map from the Drought Monitor. These are updated every Thursday, so this is last week's map. And you'll see the red colors represent extreme drought, and then that purplish color is unusually extreme drought. They had to invent that color just a couple of years ago. And these maps are vivid testimony to the arid conditions in the western United States the end of this summer, and in particular in the headwaters of the Colorado River. And many of you have heard about water supply challenges in the Colorado River, and this is affecting everybody who lives in the drainage of the Colorado River, but it's also affecting us along the Front Range. There's almost 5 million people living along the Front Range, and we rely on Colorado River water for our water supply. The tunnels underneath the Front Range bring 50% of Denver's water comes from the Colorado River, and the water supply in the Colorado River system is dropping. That's the graph on the left with the blue line shows a 10-year running average of the water supply in the Colorado River system. And then the demand for that water is the red line. And you can see that the blue line is sort of going down and the red line has been going up, although we've been using water more efficiently in the last 10 or 15 years. but the curves have crossed basically, and there is an increasing demand for a diminishing resource. And this is going to become more and more evident to residents of Colorado, residents of the western part of the United States, and water supply is going to become one of our greatest challenges. And it's going to change the way we live on the land. It's going to change the way we use water, and it's going to change the way we do agriculture. And I think we might fly over to the San Luis. Well, let's cover. This has the flow. Yeah, I want to show the flow in the Colorado River is diminishing. That's the graph on the left. And again, you can see it's noisy, meaning that year-to-year variability is great, but it is generally diminishing as you go from 1900s to the 2000s. And at the same time, on the right-hand side, you're seeing a graph that shows actually the volume of water in combined water in Lakes Powell and Lake Mead. And you'll see that the lakes filled up in 1980, and then in about the year 2000, it has been relatively dry, and the water levels in those two reservoirs, as you might know, are very low. The volume in the lakes is roughly half or less what they used to contain, and there's a tremendous bathtub ring around both Lake Powell and Lake Mead, and it's threatening our ability to generate hydroelectric energy from those reservoirs. We're going to look at the impact now on agriculture in Colorado. We've stepped west of Denver. We've crossed the Sangre de Cristo Mountains. We're near the Great Sand Dunes in the San Luis Valley. And you can see the green circles in this valley. Those are irrigated areas, and they're irrigated by center pivot irrigation. Much of this was derived from groundwater. And one of the principal crops in the upper part of the San Luis Valley are potatoes. And very rich ground in this area. The potatoes grow quite nicely if you've got enough water. The land is very flat, and there's no trouble sort of setting up one of these center pivot systems to irrigate ground to grow potatoes. And we're zooming in here. We're just east of the Great Sand Dunes, and we're right on target. And we're going to come down to one of the largest alligator farms in Colorado. And it's a remarkable phenomenon where they were drilling an oil well, and they didn't find oil. They found 82-degree Fahrenheit water, and it's water that's warm enough to please an alligator. And these alligators grow to great dimensions. It's in conjunction with a tilapia farm, and as the tilapia wear out, they're fed to the alligators, and the alligators get bigger and bigger, and occasionally they break loose. There's a little village called Mosca, and the alligators crawl under their fence and they head for the bright lights at Mosca, and they'll do this in the winter and the fall, and they head over towards they're heading for the bar in Mosca. And Chun's going to get us in close enough that you'll actually see the gators here in a minute. But they break out of that fence and they head for the bar, and then they get so cold that they freeze up. And the people from the gator farm find the gators sort of frozen up, and they pick them up and haul them back and stick them in their hot pool and feed them another tilapia. And you can go there and take gator wrestling lessons. And once you're certified as a gator wrestler, they'll allow you to come in and wrestle these guys. And you can see them imbricated against an island there in that lower pond. And we're pretty sure those things are alligators. And it might be we're being a little bit poetic licensed here, but there are 10 foot, 11 foot, 12 foot long alligators, and they're quite astonishing. But the alligators are a sidelight. We're really here to talk about the effect of water supply changes in the San Luis Valley, and the just across the street from the alligator ranch, some of the potato fields are there. You'll see the center pivots. But if you look closely at some of these center pivots, and Kachun's going to choose one, we'll fly in and look at it, it's no longer growing potatoes. And you can see that it used to be a center pivot. You'll see the circular pattern underneath it, but it's got a grid on top of it today. And I'm looking for it in the chat, but I think many of you will recognize that these are actually photovoltaic systems, and they're replacing the potatoes with photovoltaic. And what's happening is the potatoes are being curtailed because there's insufficient groundwater to supply the potato fields, and the groundwater tables are falling, and they've been trying to supplement the water with water from the Rio Grande River. But we have a treaty obligation with the state of New Mexico, and we cannot, we must give them fresh water in the Rio Grande River, which they need in Albuquerque and the big cities of New Mexico, because they need to dilute their groundwater, which has arsenic in it. And in order to satisfy the federal arsenic standards, they have to use a blend of surface water and groundwater. And so they need their water supply, to which they're entitled. And we have a interstate compact that allocates the water, but we cannot use it for growing potatoes anymore. And so you're seeing this transition. There's one on the upper left there, and you can clearly see the old potato field underneath the photovoltaic field. And I went to visit these with a School of Mines a couple, 3 years ago, and we showed up at the gate, and I didn't have any way to really telephone ahead of time, and so I showed up hoping we'd be able to get a tour. And I had the students who were all wearing vests, red vests, so they wouldn't get squashed. And we approached the gate, and this guy came out at us with a great big grin and welcomed us and said he was delighted to see us. And I said, well, I'm sorry, we didn't have a chance to make a reservation. We're here just to get a tour. And he was shocked. He says, oh, I thought you were the prisoners from the state prison coming to clean the weeds out. And so in any case, we had a very nice tour, and he was running the whole PV field system with he had a Leatherman and he had a Zerk gun, which is one of those grease gun things. So he had a grease gun and he had a Leatherman, and his only problem was that he had to get the weeds trimmed out. And so he was hoping that we would do that. But I recommended that he get some goats. And he said, well, the goats would chew the wires. And then I said, well, there are goats of different sizes. You can get pygmy goats, and they can not chew the wires. But many of these fields that used to grow crops in the San Luis Valley will now grow electricity. We're seeing the same thing happening in the Imperial Valley of California, so that you're going to see this happening more and more. And water is becoming an increasingly precious commodity across the entire region, and it's changing the way we do agriculture. And we can change our agricultural practices. We have the ability to do that, and the water levels are, got a map coming up showing water levels in the big aquifers out on the eastern side of Colorado. This is the Ogallala aquifer, and you'll see the state of Colorado has the Ogallala on its eastern fringe out by Lyman and then to the east. And then of course in Nebraska and western Kansas and in the panhandle country of Texas, extremely valuable aquifer. The red colors represent the water level fall of more than 150 feet in some cases. And I know how thick the unit is. It's only several hundred feet thick. So when the water table falls 150 feet and the unit's only a couple, 250 or 300 feet thick, you've really taken the bulk of your resource and used it for irrigation. And clearly it's unsustainable. And this has been known for years. And the US Geological Survey has worked on this. There's a tremendous effort to get agriculture to change in the high plains area and to use more efficient systems for irrigating. And we have been experimenting with drip systems. Several of us from the museum went over to Israel a few years ago to look at efficient use of water. And there's a tremendous potential to use enhanced technology to grow crops using much less water. And we are doing that. The other thing that's happening is the water is arriving from the air at different rates. And there's a tremendous change in the rainfall pattern. This is a rainfall events of extreme magnitude and what areas they cover. And you just get the sense of the curve. You get more extreme rainfall events. Ironically, as it's getting drier, you get these increased precipitation events. And I think we've got a quick video we can run showing what happened in 2013 in Boulder. And I'll just talk over it a little bit, but most of you will remember the tremendous flood that came down associated with a massive rainfall event that fell on the city of Boulder and caused catastrophic flooding on the Boulder Creek. It came right down to where I live in Longmont, and we had fish swimming across County Line Road. We had rabbits climbing trees to get out of the water. It was an extraordinary time. So we're now going to shift. We're going to scoot forward a little bit. In the interest of time, we're going to look at changes not only in temperature and water, but also in energy use in Colorado. And we're just going to give a quick vignette of one of the big changes that's happening with the energy transition as we leave the coal production. And as many of you know, coal used to be a major source of electricity in Colorado. Both Excel and Tri-State used to use a lot of coal, and increasingly they're switching to renewable energy, primarily wind. And my electric bill shows wind having gone from 2 or 3% 20 years ago to 30+% today. And coal is dropping down to below that. And of course, we're using still a lot of natural gas. We're looking at the village of Craig, Colorado, where there's a big power plant. And the power plant is fed by a coal mine. In this case, the Trapper coal mine. We'll look at quickly. And this is the subject of a podcast that was just put together recently by the Institute for Science and Technology. Kristen and her team at the Institute have a wonderful podcast, and we'll put the link in the chat here in just a minute so you'll see it. I highly advise you to attend. It's in process right now. They've had the first 2 sessions, and there's another one coming. Kachin's going to drop us down onto this feature right here, and I think you'll recognize what it is. I hope you're guessing in the chat, but this is an active coal mine, the Trapper coal mine, and you can see the giant drag system there. It's like a giant steam shovel. It fills trucks that have tires that are 11 feet tall. They look like little toy trucks there, but those are massive trucks, and they're carrying the coal from this coal mine on a short trip over to the power plant that is the Craig power plant. And the Craig power plant, which is run by Tri-State, is slated to close in about 2 or 3 years. Again, an accelerated closure, and it's going to cause a tremendous impact on the community of Craig and, of course, the entire region of northwestern Colorado. So big changes are happening in our energy landscape. Here you can see the power plant. These are the coal stacks, and just to the north of this picture, just up above to the north, will be the power plant itself. This is the coal, and if you just move a little bit to up, you'll see where the power plant is. And the power plant has tremendous furnaces that burn the coal and that make steam, and the steam turns turbines, and the turbines generate electricity. So this is the way we've made electricity for 100 years, but it is phasing out in the United States. And many of you heard the COP26 discussion about coal, whether it should be phased out or turned off. And India and China and South Africa and other countries rely tremendously on coal. So there's a challenge for the globe as we look at energy use around the world. In Colorado, we have another major issue. We'll quickly talk about fire. We'll take about 5 minutes to talk about fire. And I think we've got a situation where, because we've been preventing fire for years, the woods have gotten thicker. And here's an image series from Utah. And if you just plunk it forward, you'll see 1909 to 48. We're looking at the same scene. Here's 58, same scene. We're going to move forward one more scene, and you'll see that the area is getting thicker and thicker, 68, and then finally 1979 and 89. And this is a challenge for us across the western United States. The forests have become dense. There's an encroachment of understory material, and it is, of course, flammable. And we are experiencing fires on an unprecedented dimension. And they're continuing later in the year. There was just a fire burning yesterday near Estes Park, and I think a tragic loss of a firefighter in an aircraft. And so it's continuing with us today. The fire season that used to go just in the summertime is now going on into the wintertime. The trees have died along much of western Colorado because of the pine bark beetle and the spruce bark beetle and other beetles. And I think if we have, I don't know if you got that beetle map, Kachun, just a quick glimpse, just to see and this is the yellow indicates areas that have been impacted by the beetles. And it's a regional phenomenon, goes up into British Columbia and into Alaska. And the beetles are killing trees because it's warmer winters and drier conditions. The trees are stressed, the winters are warm, the beetles are living through the winter, and they've infected the forests. And this map shows the areas where the beetles have impacted. It's not necessarily all the trees are dead, but the beetles have impacted the trees. And of course, they become increasingly flammable. And we might get Angie's interview here, Chun, just to hear what happened up in Calwood, which is just
Calwood
behind.
fire started October
James.
17th, a year ago, 2020. Cause is undetermined. It started out as a single column of smoke, and within 20 minutes, we had 15 to 20 foot crowns. Right away, this fire went 35 acres a minute for the first 3 hours. So that's 35 football fields a minute. With the way the winds were, we had sustained 30, gusts 60 to 80. This fire was just spotting everywhere. Our fire chief had eyes on the fire and could just see it jumping from ridge to ridge. It burned 10,200 and some odd acres. It's the largest in footprint in Boulder County history. This fire was deemed out November 14th, so just under a month. We did have snow week 2 of the fire. We did have frost week 2 of the fire, but we had so many hot spots where it just burned through all that snow. Yeah.
And we do have technology to work on both mitigating a circumstance where a fire has taken place, and also to try to thin the forest. And we've got a couple of videos we want to share with you. One of them is from Northern Water, and it illustrates the use of helicopters to put mulch on the forest ground where it has been burned. And you'll see the land has been severely impacted by fire. And then in this area, we can come in and we can crunch up some of the trees that have been killed by the fire, and we can make them into mulch. And you'll see here we're chopping down the trees and thinning them. This is a technique for thinning the trees. And there's a tool here that's an extraordinary thing. It looks a little bit like a dinosaur. It crunches the trees and it strips them and it carries them over here. It's putting them into a mulcher, and you'll see the trees being fed directly into that mulcher there. And it's grinding them up and putting them into a giant bin. And then the mulch is carried over and put into nets. There's a helicopter overhead. The helicopter will lift the net up, and you'll see these guys quickly attach the net and then scamper to the side as the mulch gets hoisted up into the air. And it's very, very dramatic, but also very labor intensive. And Angie was telling us very expensive, because they've been working on doing this up in the Calwood area. The helicopter releases the mulch onto the forest floor, and it prevents erosion and hopefully sets the stage for new trees to grow on the burned landscape. The other thing that we can do is to mitigate the danger of forest fires and to try to keep the trees thinned so that they don't burn as fiercely, we can use a similar machine. And here's a wonderful video of one of these things coming in, operating on pretty steep terrain, but it goes in and it, again, sort of like a dinosaur, it reaches out, it grabs the tree, and it can saw the tree at the base, and then it can process the tree. And you'll see that it'll actually saw the tree, and then it tips it over, and it sort of takes the branches off. It puts it in a pile. And this is a way of thinning the forest. And they can keep, the trees that are the best and the strong and the tallest maybe, but then thin the forest, with the idea being that instead of having a fire that burns so hot that it kills all the trees, if you can have a fire that burns along the ground, called a ground fire, it will cause less permanent damage. And here he's chopping the tree into little chunks and stacking them. And it's an amazing tool, and it represents a use of technology to try to mitigate. But of course, it's hard to cover the entirety of Colorado. We've got forests that are steep, we've got forests that are vast, and it's not clear that we can thin the forest enough to prevent the fires from happening. Here's a fire burning in the Pacific Northwest, and I just want to show you one of the impacts. You'll see the smoke blowing generally to the east, and the fires over the last couple of summers have been intense out in Northern California, in Southern Oregon, as well as in the Rocky Mountains. Here you'll see there's actually clouds rising, not just smoke, but there's actually pyrocumulus clouds casting shadows from that fire. And then the smoke from that fire and fires like it extend across huge areas. And you can see here, this is a satellite image of the smoke coming from California fires, and they come to Colorado. So the air quality that we experience in Colorado is affected by the fires that are happening in the West. And of course, we in Colorado live in what's called the wildland urban interface. And we've got lots of people living in Conifer and Evergreen and in other communities west of Denver that are in forested areas that are at risk. People living in the Black Forest a few years ago suffered the consequences there as well. And that's down in Douglas County and El Paso County. So the fires are increasing in size through time, and it's definitely interpreted by people studying that the impact of drying and warmer conditions are extending the fire seasons. And here you see a schematic graph illustrating the change in millions of acres of fire through time, with the orange wedge being that associated with the drying conditions tied to climate change. So Colorado is seeing change in many, many dimensions. We're going to finish up with a couple of scenes of change in the Front Range area. The first one put together by the U.S. Geological Survey. And I just want to emphasize to you how much it's changing and how rapidly it's changing in our own backyard. And here's a view that goes from Denver to the north up towards Greeley. And the purple is the urban area of Denver and Greeley. This is 1960. And you've got Fort Collins up at the far north. And if we move forward 20 years, here's 1980. You can see the purples have gotten much bigger, and the black are oil and gas wells. We've got one more scene from the year 2000, and you'll see that the Denver and Fort Collins have grown, and the oil wells and gas wells have grown tremendously as well. We might just run this triplet again, Chun, just for emphasis on how much it's changed. So there's the 1960, and then here's 80, and here's 2000. Now, if we zoom in even closer, let's go to Boulder County, and we'll see changes going on in Boulder County on a similar time scale. And in Boulder County, we're looking at the development of open space. And so here's the Boulder County outline in 1975, and the Rocky Mountain National Park and the U.S. Forest Service land is shown as preserved. And then we step forward to 94, and you'll see the green represents open space lands. And here's 2007. We've got conservation easements. And then in 2021, our last map, which is about to come, you'll see a tremendous blossoming again of open space, conservation easements, and preserved land. So again, these are tremendous changes in the scenery of Colorado in just the last few years. And I want to emphasize this, we might run this through again, but I want to emphasize that we're seeing what we call the great acceleration. We're seeing a rapidly changing landscape that's changing at an increasing rate. So the rate of change is changing, and we're seeing change at unprecedented scales in so many different things, whether it's temperature, water supply, style of agriculture, and even preservation of land. And so there's a lot of stories here that can be told about the changes that we're experiencing, all of us here in Colorado, as our footprint goes from being the simple steps across a playa lake in New Mexico down at White Sands to now a footprint that weighs heavily on the land, not only in Colorado and the Western United States, but across the entire world. And we've got using the technology of the planetarium at the Denver Museum and OpenSpace, which Chun has been flying here, we can see these patterns of change across the entire globe. And these are issues that are being discussed every day. Every newspaper you see will have it. The COP26 meetings in Glasgow, it was featured heavily. Our colleague Talia just came back from Glasgow and reported on activities there. And in some vocabulary, there was a disappointment that there was a lot of blah, blah, blah going on those meetings. But I think if you stand back and think about the fact that you've got the entire world coming together once every few years at these climate conferences, people are paying attention, people are making changes. And here in the United States, we're making dramatic changes. Our energy portfolio is changed drastically. It's not easy. We're losing coal mining jobs. We're losing jobs in Wyoming and Western Colorado, but we're gaining jobs in areas where we're putting in photovoltaics, as we've shown, areas where we're putting in wind farms. tremendous amount of energy now coming from wind. And in the United States, a significant part of our portfolio is nuclear. We have 20% of our electricity in the United States is generated by nuclear power. We have 56 power plants in the United States, nuclear power plants. And not only is it 20% of our electricity, but it's 50% of our carbon-free electricity is coming from nuclear power. Other countries have done the same. France, for example, somewhere north of 80% of their electricity comes from nuclear power, but our 20% is bigger than their 80%, meaning that we generate more electricity in the United States using nuclear power than does France. And there's, of course, tremendous innovation going on right now, looking at ways in which we can use nuclear power more safely. And we're looking at distributed, smaller nuclear power plants. There's a tremendous interest in taking the technology that the military has pioneered for aircraft carriers and submarines and using those kinds of power plants to generate electricity for municipal use. And we have a wide variety of strategies that we can use going forward as we enter these changing times. And I think that the message that we try to convey from the Denver Museum through our medium is that the future is challenging, but the future is exciting. There are wonderful opportunities for young people to have careers in a wide variety of disciplines that include water management, energy management, population management, and that there are opportunities to take technology gathered from across the world, whether it's efficient water use from Israel or innovative energy technology from Denmark, and apply it here in the United States and in Colorado. So I'd like to finish with just that last thought that while we see the impact of mankind as being tremendous and in many cases damaging to the environment, we also see the capacity of our species and of our scientists and of our culture and people to find solutions. And we are seeing those solutions applied across the United States and here in Colorado in so many different ways. And I want to encourage all of you to, as you look at the views of Colorado, as you see the views, think about how they've changed in the lifetimes of yourselves and your families. And those of you who are mentioning that you've been here for 50 years, 60 years, your parents for 90 years, think of the changes that you've witnessed and think of the changes that your children and your grandchildren are going to see. And recognize that we have the capacity to make Colorado a wonderful place for our children and their children, and that the future smells good. And with that, we're just about 2 or 3 minutes past 8 o'clock. And I think, Mitch, if you've got 1 or 2 questions, we might have time for some questions and answers, but we are very grateful for all of you for coming and participating. We invite you to come to the Denver Museum. We're open. We invite you to stay tuned for future programming on Digital Earth. We've got a program coming up in December on biodiversity. It's going to be on December 7th. And we invite you to join us the evening of December 7th. And thank you all very much for attending.
Yes, thank you so much, everyone. And if you have to, it's past bedtime. If you need to go to bed, we totally understand. But if you'd like to stick around, we do have a couple of questions. One of the first questions is, someone noticed on the pine beetle map, there was a significant difference between the, like right at the US-Canadian border.
Yes, indeed. So,
change.
That's an interesting compilation, and that's a sharp eye to see that. We have had numerous maps made, and that's a state or federal and national boundary problem. We are mapping differently in the United States than they were in Canada, and those maps are made by people sitting in airplanes detecting beetle damage. And the Canadians had a different way of measuring than we did in the United States. So that was a state, that's a national boundary phenomenon on that map. But
there's also a time difference too. So the US one actually covers a slightly different time period than the Canadian one. So we aggregated data sets, not only from different agencies, but these different agencies were operating on different time scales.
Yeah.
All right, so a little bit of data collection indication there. So another question is, there's a lot of people moving to Colorado. and yet we have less water. Is anyone coming up with a plan to have more water for more people?
Well, if you might have noticed in the news, just in the last 2 or 3 days, there's been discussion by Denver Water. They're trying to enlarge a reservoir in Boulder County. And Denver Water is desperately trying to figure out how to store more water on the east side of the Continental Divide. There was a lot of resistance, but they've been granted, at least the most recent lawsuit was settled in their favor. So Denver Water will be expanding a reservoir that's designed to take Colorado River water that they own. They have the water rights to it. But as we showed in our graphs, there's diminishing amounts of water in the Colorado River. So there will be increasing challenges as we look at how we share water across the Continental Divide and amongst the states that rely on the Colorado River. And I want to emphasize that although the population is going up, we do have a tremendous opportunity to study how we use water. In Colorado, 80% of our water is used for agriculture. We're irrigating ground, and much of our agriculture in Colorado is growing hay, alfalfa, and cow corn. And so we are growing a huge amount of cow food with our water. And if we were to diminish the amount of cow food we grew, if people perhaps might consume less beef, if diet habits change, beef demand goes down, cow food demand goes down, and water that was used for agriculture can be diverted to municipal use. The municipal users can use it more wisely. And there's all kinds of ways in which every one of us can use less water. And then our scientists can figure out ways to recycle the water more efficiently, as we're doing in the city of Aurora and as they're doing down at Colorado Springs.
And this is Gross Reservoir, which is the reservoir that Denver Water is trying to expand.
Right. So it's located, it's sort of hiding behind Boulder. People don't really know it's there, but they're trying to raise the level of the dam. They've got an engineering plan to raise the level of the dam and store more water, but it's Colorado River water from the Moffett Tunnel that fills that reservoir.
All right. That's good to know that people are thinking about it. So if you remember the last visual you had, someone was asking if the brown haze showing was smog.
No, it wasn't. It was just a mistake in the visualizations. And I had actually lost control, and which is why we were kind of spinning.
All right. Well, sharp eyes. Also, to everyone out there, I put a survey in the chat, which if you have a moment to fill out the survey, that would really help us. And yeah, and if anyone has any more questions, feel free to put them in the chat. And otherwise, Bob, do you have a final thought?
Well, I'll just say one thing, the reference back to the brown smog or what have you. Those of you, again, who've been in Denver for a long time will remember the brown cloud, and you'll remember the poor air quality during times of inversion. And we still have poor air quality from time to time in Denver, but it's nothing like it was back in the 1960s and 1970s. And that's because we've cleaned up many of the sources of air pollution, which included the ground up sand on the roads, but it also includes the smoke from industry and the smoke from tailpipes of cars. And so a lot of the visual pollution has been mitigated. Of course, the carbon dioxide is not visible, and that is present with us in increasing amounts. The other thing that's happening is we're studying the air quality with increasing rigor, and there's organizations like NOAA that are investigating air quality in the Denver Basin and the Front Range region, and they're studying the impact of the oil and gas production that you saw in that one set of maps, which there's tens of thousands of wells in the Denver Basin, each one of which has some associated air quality issues. And those are things that you'll see active legislation going on right now in Colorado, for example, to limit methane leakage from the oil and gas industry. So my final thought is, again, to underline what I said a few minutes ago. I think that we live in challenging times, but we've got tremendous technology, we've got tremendous institutions, we've got a tremendously well-educated public and young people that want to make change. And I'm familiar with the Colorado School of Mines. There's an entire population there that's eager to get out of school and to help make the world a better place. And I have every confidence that we're going to see that happen. We're coming down on the zoo here. We might look for elephants in the elephant enclosure as we the elephants are right there near the on the left-hand side. And sometimes if they're not out, you can't, but I might see 2 elephants there. Chun, I think I see 2 elephants. So this is the elephant enclosure at the zoo, and we can discuss whether they might really be, potted palms or something, but they could be elephants.
You have sharp eyes from a satellite view. We do have another question, which is a very Colorado question, which is what's the effect, how much water is used by the cannabis industry?
Well, that's of course an interesting question, and I have no answer, but I think that you could probably figure it out by figuring out how many pounds of cannabis are grown every year. And I suspect if you compare the pounds of cannabis to the pounds of alfalfa, even though they do water their cannabis plants, it's a small drop in the bucket compared to the agricultural impact of large-scale Colorado agriculture. So, you compare a center pivot irrigation system to some, reinforced greenhouse somewhere, and it's a completely different scale. So I think that it's an interesting question and one that does warrant being answered, but my back of the envelope imagination is that it's going to be a small number compared to the bigger picture of larger scale agriculture.
All right. Well, thank you so much, Bob and Kachun. That was a wonderful program. I only had to Google 2 geology words, orogeny and imbricate. But
Well,
I learned something.
orogeny means mountain building. It comes from oros, which means mountain, and genesis, which means Genesis. And then imbricate, I don't know quite where that word comes from, but those alligators might have been imbricated.
It means it's an overlapping pattern. For those of you
it means
who haven't
this,
had a chance to Google
by
it.
this. Yeah.
So thank you so much, everyone, for joining us. I hope you'll join us next month. Is it? Sorry.
Yes,
it's
going to be in December, and our next Digital Earth is going to be on biodiversity, and it's on Tuesday, the 7th of December.
Thank you so much.
That's actually an academy show.
Digital Earth Academy. Fair.
That's our school program.
So let's take a moment to advertise that. So just it's high on our agenda because we're all going to be working on it. But you're seeing Digital Earth for the museum. Public done in the evenings. We've got Digital Earth Academy, which runs in the daytime, and it's designed for school children. And we use the same kinds of tools and similar technology, and we address grade school children from the East Coast of the United States all the way to the Yukon Delta in Alaska. And a wonderful program through the Denver Museum of Nature and Science, and it's underwritten by an anonymous donor, and it's been an absolute marvelous success. So absolutely right, Kachun. So it's our next Digital Earth is probably going to be in next year. I don't know if we have it scheduled yet.
All right. Well, thank you everyone for joining us. I'll just put a link to the Digital Earth Academy in the chat. And yeah, whenever you can join us again, keep an eye out for Digital Earth and come by the museum. And thank you so much for joining us tonight. And everyone have a wonderful evening.
Good night. Thank you.